Open and closed tubes. A group of students in a physics lab perform a series of experiments with a set of tubes and a tuning fork. In the first trial, they use a tube where the length can be adjusted. The students adjust the tube length, and when L is equal to 0.50 meters, they hear a loud sound indicating the first resonance. And we'll be using this for our speed of sound. A. Determine the wavelength of the sound wave. Then B. Determine the frequency of the tuning fork. In the second trial, the students use a tube with a constant length. They place a cork stopper with the same diameter as the inner size of the tube into the tube. The cork can freely move within the tube. The tuning fork that was used in the first trial is now used in the second trial. C. Determine the minimum length L0 of the left side of the tube when the air column resonates for the first time. D. What is the length L of the tube when the air column resonates for the second time? The third time. A. Determine the wavelength of the sound wave. So here's our given. It's an open tube, and we have that information. Use the equation for the wavelength of a sound wave in an open tube. That's lambda is 2L over N. Here's L. Here's N. We're taking the first one. And our lambda is 1.00 meters. Determine the frequency of the tuning fork. The wavelength for the first resonance was found to be lambda is 1.00 meters. Use the frequency-wavelength relationship for the frequency of the sound wave. The frequency is the same as the tuning fork that generated it. So F is the velocity of sound over the wavelength that we found, so our frequency is 340 Hertz. Now we have a closed tube. And here's the frequency of the tuning fork and the velocity of the sound. And that frequency of the tuning fork is not going to change. Determine the minimum length L0 of the left side of the tube when the air column resonates for the first time. So this time we're using the equation for the wavelength of a sound wave in a closed tube, which means one side is open, one side is closed. We have the frequency of the tuning fork, the velocity of sound, and n equals 1 for the first resonance. So this equation is 4L over n, and we want to solve for L, so we move that around a bit, and we get L is n lambda over 4, and what is lambda equal to? V sound over the frequency of the tuning fork. Substitute in our numbers, and we get L0 is 0.25 meters. That would be this distance right here. What is the length L of the tube when the air column resonates for the second time, the third time? We need to use the equation for the wavelength of a sound wave in a closed tube from the previous slide, and for the second resonance, we have n is equal to 3. The first resonance was when n was equal to 1. The third resonance will be n is equal to 5. That's because for a closed tube, n is always an odd integer. So here's our equation, and you can see the n right over here. So the second resonance occurs at n equals 3, same numbers we had earlier, and we get that length is 0.75 meters. Then for the third resonance, we use n equal 5, and we get the length there will be 1.25 meters.